partitioning, there are different partitioning strategies. And if you see the Spark code, when you repartition, Spark decides one of these partition strategy internally anyway. But if you want to have more control over partitioning, you can use this. And I have example of this in a coming slide. So there are 3 types of partitioning. One is hash partitioning, range partitioning, and you can give your own custom partitioning logic also. Now I have written a note that anytime you do partition by, better you persist it, because generally partition by involves shuffling. And if you have more than one action and you don't persist partition by output, then every time shuffling will happen. So you want to avoid it. So what is hash partitioning? It is implemented on hash-based, it implements hash-based partitions, and these hashes are based upon Java objects hashcode function. And range part, and I have an example of each of these, by the way. So range partitioning is the partitionings are based upon the ranges. Yeah, so please, we'll put the Discord server. Arun has asked to put the Discord server link. Arun, I will put it. Give me a few minutes. At the end of this, I put it. If someone else can put it before, good. Otherwise, I'll put it. So range partitioning, the partitioning, it partition the keys based on the range. So all keys falling in the same range will be in the same partition. It tries to divide into approximately equal size partitions. Each partition contains records with keys within a specified range. Ranges are determined by sampling the content of RDDs, and we'll see an example of that. So range partitioner has some constructor which take quite number of parameters. So these are the parameters which range partitioner has: the number of partitions you want, the RDD which you want to be partitioned, the order of the range, whether you want it in ascending or descending, during range partitioning, ordering method of the key, how how the key should be ordered. If you have a class called person, and person has ID, name, salary. So if you want to tell how to order this, so you implement that, pass this as your comparator, or as parameter 4. And class tag of t. In this example, class tag of t will be person.class. So these are the parameters to the range partitioner. Generally, I've seen you don't need to worry about this. You just repartition and Spark internally will decide. But in case you want control over this, then this is what it is. So I've given a partitioning example. So if you remember, we had these 2 files, user transactions and user info. So user info had user transaction and user info both had user ID as the first column. So I am reading the user transaction here, and I'm converting into key pair. So key is the first element, which is the user ID, and the value is the complete record. So the key value is a paired RDD, and you can see, it's a paired RDD with string as key and string as value, string type as key and string type as value. What is the key? The first column, which is a user ID, and value is complete record, complete row. Then I don't use all the parameters. I just tell it, give me 9 partitions, and for this particular RDD. So it partitions into 9. And for each partition, I go and print the partition. And I think, Sahil, you were asking question, maybe you can use the same thing. Go to each partition, and for each partition, print the content and see. I think you're saying some blank lines are there also, but that's how you can print the partition, the data inside each partition. And that's how you use the range partitioning. You can customize the range partition, and you can do a lot more things. I have not used all the parameters, but if you want as a homework, and maybe I will add as a homework, you can add more parameters there. And you can use all the more than 2 parameters which I've used for range partitioning. Now what I'm doing is I want to write my custom partitioner. And what I want to do in that custom partitioner is I want to have data for the cities which have vowels in one partition, cities which do not have vowels in another partition, something like this. We'll see. So this is my data set. And what I want to do now is I'm creating my own partitioner. This is Scala code, but in a Python and in a Java, you could, or a Python, Java, and R, you can create yourself also. So I create my whole partitioner. I take these parameters, and then it should extend partitioner. And this a get partition method, it has to override. And there I'm putting, this is my internal logic here, right? So this is Scala code. If you know Scala, you will understand it. But in reality, what I'm saying is, whatever record I'm getting. So here I'm getting this record, right? Let me go back. I'm getting this record. So 0, 1, 2, 3. These are the columns. 1, 2, 3 for columns. The first column index is 0. Second column index is 1. Then 3, and then then 2 and 3. So what I'm doing here is I'm getting the last column, which is the third column, which is a city. And I'm saying if city starts with A, E, I, O, U, or capital A, I, O, U, then what I do is I return 1, else I return 0. Correct. So this is my, I want only 2 partitions. So 1 and 0 will work for me in this case. So I use this, then I say the same file, and then I again convert into pair RDD. And here I'm saying, partition by new vowel partitioner, and I pass 2 because I have only 2 partitions. That's why I'm returning 0 and 1. There will be 2. If I pass 3 partitioner, then my, the custom partitioner should have, 0, 1, and 2. So that's how I, write my own partitioner. And then once I partition the data, I go to each partition and see the content there. So you can see in one partition, all the cities, which have non-vowels here, I think, which are not vowels. And here you have the city starting with vowel name A, U, I, and things like this. So this is how you can implement your custom partitioner. To see the partitions used, if you want to see which partitioner I have used, whether it is which partitioner has been used, you have the, either you did a partition by or repartition or whatever, and Spark internally has decided to use one of these, and you want to make sure which one has been used. So you can write, take the RDD and invoke partitioner method over there. It will print what partitioner has been used here. What determines the partition size? How many partition you should have? What are the factors which determines the number of cores available? And for that matter, I will say even the memory also. The size of external data sources, how big size you have, and for that matter, even your logic also. So these are the few factors which determines how much how many partitions should be there. There are certain transformations which you do, which always return the partitions RDD. I think we discussed, there are different type of RDDs. Partition RDD is one of those. So for example, if you use any of this transformation, join and all by key and all those things, then it will return you a partition RDD, which means that the data, these transformation do transform, do partition the data, and that's why returning you the partitions RDD. There are certain partition functions, and this comes pretty handy. I gave an assignment on map partitions. Whosoever had attempted had done this, so that was pretty good. The map partition you use when you initialize, when you do some infrastructure work, which needs to be done only once per partition. So if you want to do that, then use map partition. For example, connecting to database and fetching data from database is one such example. So there you can use map. You don't, in one partition, you don't have to do for record by record. You do it once in that partition, and every record will use the output of whatever you have done once. So that's where you use map partition. Map partition index, it's pretty similar to map partition. It additionally provides an index to tag the partition number. This is one example. If you want to know the index, I don't remember where I used it, but there was one use case where I needed to know the index of the partition, like which partition. If your the number of partitions are 50, then you will know in which partition, the code which is running inside the partition through the index number, which partition that is. I think I needed to create some random thing or something so that it is not unique across all the partition. So for that, I ended up getting the partition index and added that to the value which I was getting to create some sort of randomization.
Sandeep, I have a question on map partition.
Mm-hmm.
Can we do grouping inside that or no? Is it logical to do or not inside map partition?
If you want to do grouping, you are saying, I think you are asking whether I can use group by function, correct?
Yes.
I don't think you can use, because map partition is over a data frame, right? So when you have a data frame which consists of 1000 records, and you have 10 partitions, so 100 records are inside that partition, correct? So
Right.
once you are inside the map partition, then you are dealing with those 100 records only, and you don't have concept of the data frame once you are inside the map partition. So you can't use group by inside map partition.
Okay. So most of the times we will use map partition just to do some mapping or maybe creating some connections which we want to limit, right?
Correct. Maybe some infrastructure work which you want to do. For example, I want to
Okay.
initialize something. One of the initialization is database connection and firing some query to get master data. Second initialization could be, I know, just hypothetically, I'm showing some examples here, is connecting to Redshift. Maybe I want to push something into Redshift or pull something from Redshift in my partition, in my partitions. So things like this.
Okay. Thank you.
Sure. So repartitions. So you can repartition. I think we discussed repartition earlier also. You can repartition the data frame or data set. With repartition, you can increase or decrease the partitions. With coalesce, if you see the implementation of coalesce, it calls repartition only, but repartition in Spark code has a method called shuffle equal to true or something. So with coalesce, it just passes that as false. Coalesce reduces the number of partitions. It can't increase the number of partitions. Now, if you want to decrease number of partitions from, let's say, 10 to 4, which one will you use? Whether you will use repartition or coalesce? You should use coalesce, and I'll tell you why. Let's say your data is in 10 partition, which is, for simplicity's sake, let's say these are 10 different nodes. Partition 2 partition can be on one node also, but for our discussion, we are taking the example where each partition is on different node. And these are 10 nodes with 10 partitions. Now you want to reduce it to 4. If you do coalesce, what it is going to do is it is going to take data from the 6 partitions and move it to the rest of the 4 partitions which are already existing, and then create the 4 partition. If you use repartition and say from 10 to reduce to 4, it is going to take data from all of these 10 partitions and move it to some another entirely new 4 new partitions and copy it there. So shuffle will be when you're reducing the number of partitions. If you use repartition, shuffle will be more. If you use coalesce, shuffle will be less. This is an interview question which gets asked very often.
I have a question here. So in an interview, I was asked to give a scenario where coalesce would be used to increase the number of partitions.
And did they ask whether you can use the coalesce to increase the number of partitions, or did they ask you to whether?
I mean, they wanted me to describe a scenario where I can use coalesce to increase the number of partitions. I was open to assume.
You can. I'll tell you how it can happen. I'll tell you. See, as I said, right, coalesce calls repartition only. So if you see the coalesce implementation, let me see after this session, I will open the Spark code and will show you the coalesce implementation. It invokes the repartition with flag shuffle as is equal to false. Now let's say you have, and this is a hypothetical scenario, just validate it what I'm saying, but I think this is how it will work. Let's say you have 10 nodes, and these 10 nodes have 4 cores, and you have executor which is running on 10 nodes, which is taking only 2 cores. When I say 4 cores are available to Spark. It might, in reality, it might have more than 4 cores, but 4 cores you can use as Spark. Now your executor is running, which is using only 2 cores, correct? So effectively, it would mean that you can start 2 more cores, and you can start one more executor which can use 2 more cores, correct? So if you want to, if that's a scenario, that's what you have. Like you have 10 executors running on 10 nodes, and each of those nodes having 2 cores free, and whatever executors you are running on 10 cores, those are also using 2 cores only. Then you can possibly increase the, use the coalesce to increase the number of partitions, because coalesce, as I said, it doesn't involve shuffle. So in that case, it might, copy the data from each of these nodes. From, let's say, node 1, it has only one executor running. So it might create a new task and copy the data into the new task. So the number of partitions will increase on the same node itself. So it will not, shuffle any data. So same thing is happening on node 2, same thing is happening on node 3, same thing is happening on rest of the nodes. So idea is that if you have hardware available on each of the nodes for extra number of tasks, then this might be possible in theory. Does that make sense?
Sure, sure. Thanks. And also follow-up question on coalesce. So you mentioned that in coalesce, if we have 10 cores, and we are doing a coalesce for 4. So what it will do is it will pick up the data from 6 cores and move it to the remaining 4 cores.
Correct,
Right.
correct.
So how would it pick those 4 cores where it wants to save the data at the last?
So I think it might not be deterministic. So one thing which Spark does internally is an cost-based optimization. So I'm assuming same cost-based optimization, and we'll talk about cost-based and rule-based optimizations later in our sessions. Not today, in coming sessions. I'm assuming some cost-based rule it might be firing, and actually I will go through this repartition code later. So I'm assuming that it might be finding out if some record has some partition has more records, it will not touch it. The partition which has less record, it might touch it and move it there. But we can go through that code. I have Spark code downloaded on my IntelliJ, so we can go through that. But it might be some optimization might be happening on that front.
Okay, thanks.
Now the operations which are benefited by partitioning. If you partition the data, then there are certain operations which you can, which you can perform better, which you can do better. One is group with, second is co-group, and I think most of the things but we'll discuss many of the things here. Co-group, join, left and right auto joins, group by key. See, anything you have by key, anyway, it will get benefit by partitioning because data for the same key might exist in the same node. And lookup. There is one, I think that covers our that covers our partitioning thing. Let me open IntelliJ because we will go through certain code later, not right now, towards the end of this session. So let me open that in the meantime parallelly. So now there is something which is called Spark implicits, and this Spark implicits is basically for Scala only, and this is very helpful. And how is that helpful is I'll explain with an example, then we'll cover these points later. Let's say you have this data set, the delimiter is semicolon here, if you notice, and it has, some ID, name, date of birth, salary, designation, manager ID, address. Now what I do is I create a, where did that go? I create a case class with the same, schema, ID, name, whatever. Correct? Now I read this. Now one thing, if you see, right, when I'm reading this CSV, I'm passing header true, delimiter this, I'm loading this file. This file is spark.txt, and I'm loading it as info. This info is a case class, and you will get a data set of type info. How did that happen? That happened because the names which are appearing here are the same names which are appearing in the class, case class. And most important thing, I have done a import Spark implicits. If I do not do that, if I do not add this record, then what is going to happen is it's going to give a compilation error here. Your code will not even compile. IntelliJ, if you run on Spark shell, it will throw error. So what this Spark implicit does is it automatically takes this columns, ID column, and put it into the each record becomes for each record it gets an instance of info class, and populate the value accordingly. Like ID goes into the ID field of that class, name goes into name field, and so on. And that's how you get the the data set of type info. It's only for Scala. It helps implicitly converting Scala objects to data frame. That's what we saw just now. It implicit object is defined inside Spark session. So inside it is doing that. So now what does that mean is, in your code, if you import the implicits before creating the Spark session, then this won't work. You'll still, on your IntelliJ, you'll still keep seeing that error. So as soon as you create the Spark session, immediately after that, you say import, spark.implicit inside your method itself. In Java, you can't have import inside the method, but in Scala, you can have import inside your methods also. So the moment you create a Spark session, you import the Spark implicit, and then this will automatically happen. It will automatically convert your data set into the case class or whatever class you have, and you'll get data set of that class. So that's why Spark implicits are pretty useful in the Scala code. I think this covers our first module. Any question? I want to jump into the second also to cover a few things.
Hi Sandeep, Ankit here. Actually, I have a question. Like, we are creating case class for the columns and then passing the data types. But what if we want to make a generic framework around this Spark so that we can implement many tables with it, so we don't have to create case class individually for each of the tables. So
this is a good question, Ankit. You complete your question, then I will add my comment to this.
I mean, I want to make a generic function in which I can just pass on the parameters, like pass on.
I got it. I will I'll elaborate your question. Your question is that this schema, this is one data set which has this schema. I met another data set which are different schema altogether.
Yes.
Right? But I want to have only one Spark program which creates, which processes this. Right? On certain common logic. This is a very good interview question. I ask this question in all my interviews, but I will let someone answer. In case someone knows the answer, I'll let that answer. Otherwise, I will answer it.
So, as per my expectation, if you don't pass the schema, Spark itself will type inference the data, and it will assign that data types and the column names based on the data what you provided. If you don't have any column names in the data, then it will mark it as $0, $1.
No, but I want to give that letter. So let me elaborate. I'm asking the interview question which I ask in all my interviews. So, I'm just reiterating as is here. So let's say I have 5 data sets. Everyone has different schema altogether. No correlation between these 5 data sets at all. Now I want to write one Spark program, and what that program will do is it will take 2 inputs, actually 3 inputs. First input it will take is where is the location of this data, which folder this data exists, which directory exists. Second is some schema information that this data has this schema. This also comes as an input. Third, what I want to do this data, some arithmetic expression. Let's say my arithmetic, all I want to do the Spark job is for all these data sets, I want to create a new column, and that new column is arithmetic expression of some existing columns. For example, for first data set, I can say first data set has column C1, C2, C3, or so let's say salary, income tax, and something. That's these are the columns, few of the columns in the data set, first data set. So my formula will be add a new column which is salary minus income tax divided by 50. Okay? That's my formula, and based upon this formula, I want to add a new column for each new column having value for each row. So then I go to the second. I want to process second data set. So I pass the location of the second data set. I pass the schema of the second data set, and I pass formula of data set. Second data set. Formula of the second data set might look like a multiplication of some 3 columns in the second data set divided by 4th column. But that's a formula. That's my Spark job. That's what my Spark job should process. And similar is the case with rest of the columns. So if you were to design such Spark jobs, how will you do it?
So, Sandeep, is the ideal solution basically in Spark, or we can answer that in PySpark as well?
You can it's in Spark. Use PySpark or Scala Spark or Java Spark, doesn't matter. But it's a Spark question.
Okay. So for that, what we can do is so the path and the formula is it's straightforward. We can once we have a data set with us, we can just use with column to generate the required features using that formula. When it comes to schema, we can use struct type and struct field to create the schema object and pass it in the spark.read function while we are reading it.
That's absolutely correct. This is the answer. I think Reshma, you also gave the answer, partially correct, but you forgot to add. Who gave this answer? Was it Arun?
This is Arun here.
So this is a correct answer. You have to create based on the schema which is passed. Dynamically, you have to create a struct type, a struct field, and that becomes your data set of row. That is your data frame. And now you pass any schema you want. So it can always create the struct field based on that schema. The data frame. Good answer, man.
So struct we will create before calling that method, right?
Inside your method itself. So once your driver program starts, maybe this is one of the homework I will give you. Once your driver program starts, then you based on the schema. Let's say I'm passing a schema with ID, name, and salary. Right? I'm passing the data type also. ID string, name string, salary is let's say number. I create struct field and struct type, and inside the type there can be 3 fields. Yeah, someone pasted that. Sahil pasted that. This is how you do it. And you have the struct type, and inside the struct type, you will, based upon that, you will create a data set of type row, ROW. So here I am showing you the data set of type info, info. But the question which Arun was asking is the multiple schema, you create the struct, and then based upon that, you create a data set of type row, ROW. O is a Spark class. So that way you can write one Spark job for any schema.
Okay, got it.
So, but good question. So now let's move on to the another one.
And
Hi, Sandeep,
one more question.
Yeah, hi, Sandeep. Vishal.
One more question, then we'll move to another one because we have Q&A session also later. Go ahead.
Oh,
Go ahead.
Yeah. So the question, the struct schema that we have created is like we have, we know the predefined field, but I guess the question was like, I want to create a generic schema. On that generic schema, I can call, let's say I have a table, 5 tables. Okay. And I want to create a class wherein I can pass all those 5 table, and I can get, accordingly, I will get the data frame.
No, for create a data frame, you need to know the schema. So somehow you have to find the schema, and it is good that way. Even if you figure out the way, what you are asking, Vishal, I will still not recommend it because then Spark Optimizer will have problem optimizing what you are building. If you give the proper schema, and you can create schema dynamically at runtime, so I don't see any problem there. But if you with that capability and having the proper schema, Spark can optimize your job much better.
So can we create dynamic dynamic schema? For an example, the case class that
Sahil pasted that. That's how you create a dynamic schema.
Okay, fine.
Yeah, Anshul, you were asking something.
Yes, I was asking like, is there any other place where we will use a Spark implicits?
Mostly you use at this only. I have seen, I have used only at this place. I am not seeing any other example. Basically, Spark implicits are, if you don't have Spark implicit, use an encoder, right? What you are all asking is, it's becoming confusing because Spark is doing this job for you by using implicits. Assume that Spark says, no, there is no more implicits. Then you will be creating an encoder. And I have an example of that also. The moment you create an encoder, you have to create the schema like Sahil had tested. So you create the schema, put that in encoder, and then create data frame out of it.
Okay, because I remember in some of a project where I was working, there was implicits created by someone already. So that method used to get called automatically. I know it half, but I thought like maybe I can understand it, but custom implicits, I believe.
I think what you are asking is, in addition to what Spark gives,
yes,
what happened? In addition to what Spark gives, can you create your own implicits?
Yes. And in which scenarios we will create it?
See, what implicit is doing is, in this case, it's trying to, you don't need to create encoders yourself, right? You don't have to define the schema for yourself. So it's trying to save that effort. So anything which Spark can do based on the configuration, see, it is in combination Spark and Scala together. So anything which can be done based on some configuration or based on some standard. Here the standard is at a name or of the same type as here in the schema as here in the class, correct? So anything similar which can be done based upon some standard or some convention or some configuration, there you could create the implicits. I'm anticipating many use cases of implicits based on this, but it depends from your use case to use case.
Okay.
Okay, let's go into the, I think this covers our module 1. So module 1 and 3 are the biggest one. In total, we'll have, I think, 6 modules. 4 and 5 are pretty small. 3 is biggest. If we cover 2 small, if we cover 3, then almost we are done with the course. So let's go into the RDDs. We'll cover some RDDs here. In practice, you will not be needing to deal with, with RDDs. People, can you go on mute, please? You will not be needing to deal with RDDs, yourself. In rare scenarios, when you have the need to deal with RDDs, for example, you need some RDD functionalities, and some of this functionality we'll talk about here. So if you want to go to low level details and have to deal with the RDD functionalities, then only use RDD. But you should know what are the things, what are the types of RDDs are there, so that in case you need to know, you will be aware. There are many RDDs, by the way. I have captured only few which I thought were of importance. One is double RDD, second is pair RDD, order RDD, sequence file, co-group, shuffle, and new. And we'll go into details of each of these. So what is double RDD? Sorry, let me go back. Double RDD has extra functions which are related to double values. For example, you can create histogram, mean, etc., etc. So just for an example, I have this records. In order to create a mean, I can do this here. Sample variance, I can create because it's double RDD. You see, this RDD is double, so I can say double RDD dot sample variance. It gives the sample variance. I think I have a couple of more examples. The system is a little slow somehow. Stats. So you can come up with the stats. So you can say your the RDD dot stats. So it'll give you count, mean, standard deviation, max, min, and things like this. By the way, if you ever worked in Hive, so if you go to Hive table, what they have done is the Spark. So there is a group of Hawaii. They have added a cost-based optimizer in Spark. The way the cost-based optimizer works on Hive basis, when Spark is dealing with data sets in Hive, is they have created a command called analyze table name compute statistics. So if you run that over Hive table, that also gives you something similar. It will tell you, it gives you a little more than that. It will tell you what is the size of that table. Like if you're saving in Parquet, what is the size of that table in Parquet format, and Parquet is highly compressed format. And then it will give you what is the raw size also for this. If it were not in Parquet, for not in a normal uncompressed format, then what is that? What is the row count and things like this? That also gives you lot of that information over Hive table. But if you're talking to the double thinking about double RDD, then you can use this in a sample this stat to give you all this information. So is this limited to doubles or any RDD dealing numbers? You can do this. These methods, sample variance, sample standard deviation, or stats, are double RDD only. If you have RDD of some other type and you try to invoke, it won't work. It will give error. And you can see the details of double RDD on this link. All the functions are mentioned here. Okay. Pair RDD, when you need to deal with key value pairs. For example, group by key, many by key. You'll see many by key functions, combine by key, reduce by key. So they use pair RDD. The way you create pair RDD is like key and value. So I have seen in the you saw in the previous example also. I created a pair RDD. I had this RDD lines. Over this lines here, and invoke the map function. And in this map function, I create 2 values. So incidentally here I'm creating the first column as a key and the complete record as a value. So this becomes my pair RDD. Key as the first column and value as the complete record, including first column also. So this is how you create pair RDD.
Sandeep, like if we had to do the similar function in data frame, so we would use like flat map. Is it? Like
depending upon what data you have, what function you want to do in data frame. If you want to apply some map function, you can just apply simple map function, right?
No. Basically, if for each row we want like 2 values, like we want to apply 2 functions on each row, then
No, I'm just thinking because your data frame of type row, it can have 2 columns, right? This RDD is only RDD has key value pair. In data frame, there's nothing like key value. Just a data frame is just a tabular structure.
Right.
It's not like, so if you want to have 2 columns, you for sure in your data frame when you create the row, one row can first column the row can have key, and second column of the row can have full value. So
Okay,
that way you
so
can achieve if you want.
okay. So where do we use like flat map transformation that we have?
Flat map, you have not seen the previous recording. So flat map we use, let's hold on to that. I will answer.
Okay, yeah.
Just, type your question in the chat. We'll come to that later. Okay. Ordered RDD. Where the key is sortable, correct? Where we can sort the keys. You can define your own ordering for custom types. So for example, sort by key. So this is an example. So I have created, this list, a paired RDD with the city and some number. Then I sort by key. So it give me, some shuffle RDD. Then I collect it. And then because I've sorted it, so then now it becomes, sorted by the key is the Bengal, so it's sorted by the key, B, C in alphabetical order, right? I can sort, this sorted RDD, I can, say filter by range. I want to get from A to G. So any, key which has from A to G that comes outside G, like M, P, H, they don't appear. So this is one function of the ordered RDD. Reduce by key. I think this you must be knowing all by now. So reduce by key is basically, it's again transformation function, and like any other function, like any other transformation, it takes another RDD. It takes first value as accumulator and second value is as a value, and I'll have an example of that in coming slide. Now, when you are dealing with things like where you have reduced by key, and I think there is one aggregate by key or something, you need to know what is associative property. And I have explained it with example also in later, associative and other properties also. But associative properties says that you can add or multiply regardless of how the numbers are grouped. A group we mean by how you use the parenthesis. So if you say 4 plus 5 in one bracket, then plus 6. So it's a 15 versus you say 4 plus, then in bracket 5 and 6, that will also be 15. So that's what associative property. You can group number in any way you want, and that gives you the same result. There's summation or multiplication or everything. It merges the value of the same key. I will explain with an example how does that happen. It takes functions and input which has 2 parameters of the same type and 1 element output of the same type. Okay, it uses a local combiner. Let me explain with an example. So let's say you have this pair RDD. So anything where you use by key, it works on the pair RDD only. So you have key and value. So if you see A is repeated many times, B is repeated many times, etc. So one reduce by can do is there are 2 parameters, accumulator and N. So how does that work is I have so it'll take first accumulator will be 0, of course. Then we'll take A and it will be 1, right? So 0 plus so key is A, right? For each key is doing separately. For A, it is summing up. So what are the values of A? 1, 2, 3. So it will sum 1 plus 1 plus 1. So it becomes 3, right? You can see A3 here. So parallelly, because B is a separate key, so same operation is happening for B also. Accumulator, it takes the accumulator which is initially 0, and then it takes the value. Here it will take first 1, so 0 plus 1 becomes 1. Then it goes to the B. Again, B says, okay, one more is there. So previous summation was 1, and the new value is 1. So it becomes 1 and 1 here. So 1 plus 1, 2. Now accumulator has 2 value is 2. And the next B has 1. So it becomes 2, 1. Then 2 plus the 1 becomes 3. So that's how it is passing. And then you see the B. And this is the output of for the B key also. This is just a syntax. You can use this function, or you can create this function beforehand. It's a scalar syntax. You can create a function and say accumulator and whatever some parameters and what is happening on those parameters. This is a function you created, and reduce by key, you are passing that function. So result is same. Group by key, it's again transformation functions. but it involves a lot of shuffling. It is similar, we'll see the difference between group by key and reduce by key in coming slides. It's costly because it shuffles all the records, and it always returns in the hash partition RDD. If you see the implementation of group by key in your Spark code, it will be using hash partitioning and partitioning data based on the hash and giving the hash partition RDD. And it is not recommended. It's not recommended, and you will see why it's not recommended. But let's see the example of this group by key. It's same. You have some country and whatever, and you're grouping it by. So got num partition. So group by key 2. So basically, it's very similar to you're grouping. You generally with group by, you just give some aggregate also. That's what you're doing with that group by. And here I'm not doing aggregate. I'm using group by key and just giving number of partitions. It will give me 3 because there are 3 distinct countries here. So here group by key 2. So it will have the 2 keys going to the same partition. And total overall keys will be 2. So you can say number of partitions will be 2 because I told it to use 2 partition. In one partition, it will be having more than 1 key. This is a pictorial view of why group by key is not preferred, why reduce by key is preferred. So if you have, let's say these are 3 partitions, and you have a comma 1, b comma 1. Now here you see a comma 1 is repeated and b comma 1 is also repeated. So this also has some repetition. If you use group by key, then what is going to happen is 2 elements from this and 1, 2, 3, 4 elements from this, and 6 elements from this will be shuffled. If you use a reduce by key, of course 2 will be shuffled from here, but from here there's a local combiner which is working. So let's say reduce by key, I'm doing some summation. You saw the summation function above, right? So if I'm doing some summation, so those summation will happen on that node itself first. So a comma 2 and b comma 2 instead of 4, it will transfer only 2 elements from this 2 records from this node. And here instead of 6, it will emit only, it will transfer over, or it will shuffle only 2 records from here. So this is okay for 2 and 6, but you think about millions and millions of records. So with this reduce by key, how much network traffic you are saving? So that saving is huge. So that's why reduce by key is always preferred. There's a SequenceFileRDD. What is SequenceFileRDD? If you've ever worked on MapReduce, then sometimes you need to in the MapReduce word generally it happens. You need to save the data as key value also, and that's one problem which sequence file saves. Solves. Other is that when you have Hadoop and for that matter even Spark is this, it works best when you have when you don't have small files. We have very, very small files and performance suffers. So in MapReduce word, if you want to solve that problem, you can use sequence file there as well. And if you want to use that, if you want to take the same advantages into the Spark, then you can use SequenceFileRDD. I have an example of that. You can go to the sequence file format on this wiki. It is explained very well. It works on PRDD because sequence file is key and value, and you can generate or read sequence file. And I like an example here. So let's say the same data, ID, name. I showed you the data in the previous slide, which has ID, name, salary, manager ID, and everything. I'm reading the same data in text file, creating a pair RDD, and then I save this as a sequence file. Right? You can save as a sequence file also using or RDD function. You save a sequence file. Now I want to read the sequence file. I just wanted to see how the sequence file reading works. So using Spark session, I read the sequence file, and pass a sequence file, and then there are certain parameters. What is the value of key? What is the type of key? What is the type of class? And all those things. So I read all of that sequence file, then apply some. It gives me the key and value because sequence file is stored as key and value always. So it gives me key and value. I just print that key and value, and I will just convert that to string and give. That's all I do, and I collect it. So that's the result I get. So idea here is that if you want to, generally in your Spark implementation, you will not be using the sequence file, but for legacy purpose, or you're getting some output from some other ETL system, and you have to read that, and that output is in sequence file. So in that case, you can use the SequenceFileRDD. Co-group RDD. So co-group, what is co-group? So let's say, let's read this out and I'll explain you in words also. So in Spark, the co-group function is performed on different data sets. Let's say you have 2 data sets. One has this key and this value. Another has, it both have key and value, correct? So now when you join these two data, when you co-group these data sets, then they will be joined on the same key. Let's say, in this, let's say key is Bangalore and it has 50 records. The key is again Bangalore, it has 10 records, correct? So you will get Bangalore as a key and you get iterable over these 50 records here and iterable over these 10 records here. In the two iterables you'll get. So that's what co-group works, because it has key value. Of course, it will work on the pair RDD. So this is an example. So I created a paired RDD with some keys and keys and the number of values. Then another pair RDD have the name of the city, the type of the city. So this city sales RDD is the first city type, and you can see the Bangalore has how many records here. I think it has only one. So it will get it will get co-group with Bangalore as a key, and one record from here and one record from here. So if you have two records of Bangalore here, you will get Bangalore as a key, one record from here and two records from here in this iterable. Right? So that's how the co-group works. Shuffle RDD, you will not be able to use Shuffle RDD at all, but while debugging, while the production, you might be encountering this. You might need to dig into details of this. So Shuffle RDD happens during aggregates, and of course, because all of this the shuffle. So Shuffle RDD knows two steps: marking when a shuffle needs to take place, which is planning. So here correct, this shuffle happens during shuffle. Shuffle RDD gets created during shuffle, and these are some of the examples when shuffle happens. There might be many functions which might be invoking shuffles. These are few of those. So shuffle involves two steps. One step is marking when shuffle needs to take place, which is planning, and facilitating the shuffle execution. So when anytime these things happen, then shuffle RDD gets created, and you can go into details of this shuffle RDD using this link. Generally, I have not seen people dig into this shuffle RDD, but in case you want more information, please feel free to dig into this. Now there is this is the last one. So this is called newHadoopRDD. Now, if you ever, if anyone, if you have worked on the MapReduce world, one advantage of that MapReduce world was, and it's possible in Spark also, but it was pretty nicely designed. If I want to read data, so they have given support for reading all Parquet data, ORC data, the JSON data, and everything is there. But if I want to read my own, format, let's say I have some, XML file, which is, one document which contains many XML documents, one big file, one file which contains many XML documents within it, and each XML document is spanning more than one line. So if I have such scenarios, this is just one example. But the idea which I'm trying to tell is, if you have some custom format which Hadoop does not understand, then Hadoop MapReduce will let you decide your own format, let you create your own input split. So if you have such scenarios in Spark also, then you can use newHadoopRDD. So here, your input format class, when you say input format class, these are the parameters you pass while creating the new RDD. So first the input format class, second the key, and third is the value. Main magic lies in the input format class. If you implement your input format class, basically you will be able to parse any custom format also. Like if you have data in some binary format which you only can understand. So in that case, you create your input format class and tell Hadoop, this is my input format class. In the implementation of the format class, you will be telling Hadoop how to parse this. That's your implementation. So Hadoop will take that your parsing of your your schema of your format in this format class and accordingly parallelize the task. So if you have such scenarios in Spark, then you can use this newHadoopRDD. Let's spend 10 more minutes in going over this. So let's talk about Spark scheduler. What it does is converts Sparks into jobs, tasks, and stages. An action is a job. Each job is divided into stages. Each stage is divided into tasks, and tasks are the smallest unit of work. Each task is also called a partition as well. Correct? So it has given this example. So you're joining, there are two RDDs, you're joining and then grouping by unfilter. So this is the operation, this is what it is doing. And then there are two data sets which has two partitions, right? You're doing RDD1, RDD2, assuming this RDD1, this is RDD2, some two partitions here, and then you're you're joining and then grouping by and then filtering. So this is the join and grouping by happening here, and then filter by is happening here, right? So this is some sort of DAG it creates based upon what you are given, and then it will talk to the cluster manager, and based on this task set which is created, based on this DAG which is created, create some sort of task set, and then talk to the cluster manager. What are the cluster manager? Yarn is one cluster manager, Kubernetes is another cluster manager. Spark itself has an inbuilt cluster manager, which generally doesn't get used much. And talk to cluster manager and spin up the task on the worker nodes. Okay. So that's what that's at very high level how Spark scheduler works. I'll add the question into the Jurico platform. I think we are done with this too. I think we're done with two. Yes, this is the last slide. Let me cover only few topics from this, and then we can go into question hour session. So here we'll be covering an accumulator, broadcast variable, and then some RDD advanced operations, map partition little more, and data frame functions. We'll have we'll spend good amount of time in going to the plan of this, how the plan works, and how you can see, if your Spark job is taking a lot of time and you want to debug, you will be able to see what all is happening. So we'll be spending good amount of time here. So let's go through 3-4 of such slides. So what is broadcast variable? I think by now you all know what, sorry, my mistake. By now you know what broadcast variable is. So basically, if you have one small data set, small data, reference data or whatever data, which is not huge in size, and which can fit in the memory of worker nodes, and in your logic you need that data, so you can send the data as a broadcast variable. So the way it works is, in your Spark application, which is driver program, you have some data, some map or something is here, and you're broadcasting it. So this, once you broadcast, these are the worker nodes. So it goes into the memory of each of these worker nodes. And then on this worker node, executor is running, which might have more than one task running, and each task needs this data. You are doing multiple, transformation inside the task. So if they need this data, it is always available to them to the memory. So how does that help? It solves, the bigger data sets are here, right? Bigger chunk of bigger data set is here, here, and here. So the bigger data set doesn't need to, move anywhere. So you avoid a lot of shuffle by using the broadcast variable. And we'll explain how broadcast variable works in an example in the next slide. Accumulator. So what is accumulator? Let me read through this, then I will tell you, where I have used accumulator. So it acts as a containers for accumulating values across tasks. So these are the values, these are the tasks which are running, So if you want to accumulate some, value across tasks, then use accumulator. These are write only for executors and the task. This executor and task running inside this. So these accumulators, task can only write, correct? Accessing the value of accumulator is allowed only by the driver. So these tasks can only write, and this driver can only read the accumulator. Driver cannot write, and task cannot read. These are serializable, of course, because these are many worker nodes and the driver code needs to access it or modify it. So they have to be serializable. Accumulator can have an optional lab, which can be specified by creating it. Out of the box, Spark provides supports for double, long, float collections. If you have some data type which does not fall into any of this, you can create your own custom accumulator also. The broadcast, so we discussed broadcast variable. Let's see the example of that. So let's say I have a state, a map which has abbreviation in the full form of some states in US. Then I have country which has abbreviation and full form. Then what I do is I say spark.spark context.broadcast and states. I'm broadcasting states. I'm broadcasting countries also. I'm broadcasting both of these. Now I have this data which I read. Here I'm in this program is hard coded, but generally you will read it from a some file or some database or something. So, and this will be millions of records in this data. Correct. Now, so I have created an RDD. Now I want to do RDD or data frame or whatever. So I'm doing a map operation over this. So what this RDD contains, it has first name, last name, the country and the state. So what I do is, I do, map of each of these records, and I get the third record, which is country, and the fourth record, which is state. Then I get from the broadcast. So I got this country, which was USA, from this record, like, because I have all this data, I'm doing a map. So for the first record, I got USA, and the broadcast, I say, in the broadcast, I have passed, the states also as a, broadcast variable. So I say broadcast, and the countries also a broadcast variable, which is broadcast countries. So from that broadcast variable, broadcast countries dot value, it will give me a map. From that map, I'm saying dot get, and passing the US as a country. So it will give me the USA and USA, object, and then scale object, and know that I'll use get to give me get the data in string. So same is the case I do here. So then I say F1, whatever I got, first name, last name, and then full country and full state. Then, instead of USA, it will be United States of America. Instead of CA, it will be California, and so on for the records also. And then I print it just to check it out. So that's how broadcast variables work. Accumulators, I have given one example of accumulator. So you can, use that. And let me tell you why I was using accumulator, where I was using accumulator. See, you use accumulator when you need some information, something for informational purposes only. It need not be, it need not be affecting your business process or business logic. What does that mean? For example, when I was writing this I used in MapReduce also had similar concept. So so you could use there also, you could use in Spark as well. So I wanted to know how many, so one of the processing which I was having, so I wanted to know how many records are there which have some amount greater than 10,000. It was just for my information, not for my business logic or something. So I use accumulator there, and whenever I would found some record greater than 10,000, I will say, accumulator.add, it will add it there. And in the driver code, anyway, I could print the accumulator value. You can see the accumulator value here on your Spark UI also. We'll have good amount of session on the Spark UI in the coming days, but accumulator values are really visible on Spark UI. You can see. So because it was informational purpose only, and you can see from each executor, which how many, which executor attributed to what to come at this value. This 45. You can do whatever you want with this information. You can create your custom accumulator. I have not created it myself, but if you want to do, please write the code and give it to me. I will add to this slide also. I think I will stop here. We'll let me stop the recording.